Hello, hello, everybody. Howdy, howdy. Welcome, welcome, welcome. Sorry for being a little bit late. You know, sometimes things happen. Why physics no say what stuff is? Maybe physics say what stuff is. Physics can't answer whether physics say what stuff is. Maybe stuff physics. Maybe stuff is what stuff do. Then stuff is what physics do. What happened? Oh, I was just busy. Do I like Speechkova? Yeah, I do actually. I like Speechkova quite a lot. It's been a while since I've had it though. And I guess I can't have it anymore actually because of the gluten stuff. Because you probably can't make gluten-free Speechkova. How long have it been on? For like 30 seconds. Maybe physics only half story. Maybe. Why is max measured closure speed c even when particles move at near c? I don't understand what the question is. Why is the Big Bang Theory under fire? It's not. Let's talk about that booster that crashed to the moon. Can't come up. I'm at work. I tried to watch it last night, but it didn't happen, and I was sleepy. When did I meet Mrs. Dr. Blitz? Well, she's not a doctor. But I met her in college. Do physics be stuff that do that stuff be physics do? Indeed. Maybe physics describes only perceptible stuff. Well, yeah. What would time look like near a white hole? Basically the same, because the metric is basically, it would look almost identical. Actually, it would look identical as it would next to a black hole. Why when particles move at near light speed together is their relative speed not 2x? Because speeds don't add like that near relative speeds. Like, really think about it. Like, why should speeds add like that? How tall am I? 8'4". What is EMF? It depends on the context, but usually it's electromotive force if you're in a physics class, and it's electromagnetic frequency if you're a woo-woo person. What do you think was going on before the Big Bang? It's a great question. We don't know the answer to. If stuff is what stuff do, no thing do the doing. Yep. No thing, only thing, not do. Thing do, something. Oh, you think it's sub only? Oh, it's not supposed to be. Let me change that. My bad. My B. Sorry. Okay, let me make sure that's changed in both places. Okay, it should be fixed on the horizontal. And let me just go fix it on the vertical as well. It's not sub only on TikTok, it's just on YouTube, but let me fix it on YouTube. Yeah, sorry about that. What are your thoughts about cyclical ekpyrotic universe? I think it's a good idea. I think that Steinhardt's a clever fella. A pebble traveling at 99.9999% the speed of light hit the Earth, would we all die? I mean, it's always hard to estimate these things. Like, I could run the calculation. I guess it depends on how big the pebble is. How does gravity start on star creations? So there's something called the genes instability, which is basically so during stellar evolution, you have a whole bunch of gas, like a giant molecular cloud or a giant molecular gas cloud. And there's just a bunch of gas floating around, kind of cold. And the point is that there's gravity pulling it in, but it's a gas cloud, so it has pressure. So the pressure is keeping it in stable equilibrium. Now, if something changes, if it gets heated up, if something bumps into it, you can destabilize it, and then depending on the mass, depending on the pressure, depending on the temperature, it can collapse and start forming a star. What is the Hartle-Hawking state? It's complicated, but it's essentially a quantum mechanical description of the early phase of the universe, which essentially has a purely spatial cap sitting on top of a temporal badminton dart. No thing do the doing, no make sense. Ah, well, that's where I gotcha. What is the universe expanding into? It's not expanding into anything. That's the point, right? The universal expansion is happening within the universe. It's not happening around the universe, because there is no around the universe. Is the speed's not adding up to 2x light speed something to do with time dilation near light speed? Time dilation and length contraction, yeah. Are you taking guests? I will in about an hour. Do you believe in substantialism or relativism? What's the argument for the belief? For space-time, I lean towards some sort of substantialism, but perhaps like a what is it? A bundle theory version of substantialism, which is weird. What model of the universe do you think is most true? I don't have an opinion on it. There are things I work on, but I'm not convinced that they're true. The universe is expanding, right? What is expanding into? It's not expanding as like a thing in space expands. It's like the space itself has more space in it. People don't think the universe be like a bee, but it do. Indeed, that's true. That's true. It do be like a bee. Why come the is and not the don't? There you go. Are particles real? Yeah, they're real, but they're in some sense emergent. Oh, is my mic quiet? Oh, my mic is super quiet. I'm sorry. Okay, should be much better. Sorry for blowing out everybody's earbuds. What was your least favorite class in high school? I don't know if I had a least favorite class. I liked school. Why are there so many constants that are squared in physics? Because sometimes things be squared. There's also a lot of square roots. What's your opinion on theists using the BGV theorem for the cosmological argument? Well, they're doing it wrong because the BGV theorem is not so much a theorem as it is like a vibe. If it's expanding, where is it creating space from? How can something be created from nothing? It depends on what you think space is, but like, why can't... The point is not that like space is like an amount of stuff and then you have more amount of stuff. It's just that space, like when we say the universe is expanding, what we mean is that there's more distance between things. And distance is not a stuff, depending on what your perspective is. Particles are somewhat emergent. Well, yeah, so the idea of a particle is like an emergent thing from underlying fundamental quantum fields. These are like excitations, and so in some sense they're emergent, right? Do you think that time is a fourth dimension or that it's a property of space? It's probably a property, it's probably a fourth dimension. What do you think of string theory? I think it's good to research. I don't know it's true, but I think it's good to research. Is time discrete? We don't know. How is AI in the physics field? Are they helping you guys? I've seen seemingly helpful things. I haven't talked about it a lot with colleagues, so I don't really know how they're using it, if they're using it. The few people that I have spoken with are more mathy, but they've been using it for a while now. Do you think in our lifetime we'll figure out why the wave function collapse seems stochastic? I have no idea. Does the start of the universe lay outside the realm of time? Well, if there is something outside the realm of time, then there's no start if there's no time. Right, like that's... In the sense that particles are a byproduct of those fields, yeah. Can you explain the Planck constant? Yeah, it's literally just a number for converting frequency to energy for photons. That's all it's there. And then it happens to show up everywhere else too. Could the expansion be a large spiral? No, it doesn't seem to be. Would there be any plausible way to observe gravitons considering traditional methods are lackluster? And there was actually a study that came out, or a paper that came out, I don't know, a few years ago that suggested that even if gravitons are real, it might be physically impossible to measure them. Is it fair to say that the universe doesn't have a size since there's nothing to compare it to? Well, what you can do is you can talk about the actual size of the observable universe. It's some number of meters. But you know, that doesn't really, that's the observable universe, not the whole universe. What is the current best alternative for string theory and fundamental physics? There isn't really an alternative to it. Not that's nearly as well worked out. Do you think the probability of other life is possible? And if so, what about intelligent life? Yeah, it seems likely. Is gravity truly the cause of the collapse of the wave function? Should we gravitize quantum mechanics? That's what Penrose would have you believe, but I'm not convinced. Do you like the idea of quantized inertia? Not really. Like, why would it be quantized? Can you fight flat earthers like with my fists? I mean, probably. I'm 8'4". If space emerges from entanglement, what could prove it's truly being created, not just redescribed? Well, look, the point is that emergence is not creation. Emergence is just a higher level, kind of zoomed out version of the same thing. Is time a physical thing? In some sense, in the sense that like there are laws of physics that tell us how time behaves. Yeah. From Matt Lloyd with the £5. Thank you so much, Matt. Hi, Dr. Blitz. Hope you're well. No questions yet, as I'm still reading my physics books, but I'm gonna come up with a doozy eventually. Good luck. Good luck. What would it mean if multiple temporal dimensions exist? It would mean that we could time travel. Do they know there was subatomic particles before atom smashers? Yeah. I mean, like, we've had particle accelerators for a long time. Cathode ray tubes, you know, the things in the old TVs, those are a kind of particle accelerator. It took us a while to figure out that they are particles. But if you consider, you know, cathode ray tubes to be particle or atom smashers, then yeah, we did have them. We just didn't know why they behaved the way they did. Do you think protons decay, and if so, how slowly? I am on the fence about it. I hope that they do, because that would be really, really neat, but it'd be nice to have some sort of result in fundamental physics like that, but we have no evidence. From the POV of an ultra-relativistic neutrino, you're actually super short. No, I'm actually super thin. At least 2 time dimensions in some sense, right? Forward and back? No, forward and back is 1 dimension. Emergence is generally some form of grounding relation between what emerges and what emerges from, right? Yeah. Is the universe expanding faster around the edges, and if so, does that mean it's expanding in rotation? The universe is not rotating as far as we can tell, and the universe also doesn't have edges. Now, the observable universe does have edges, but it's not expanding faster there. I mean, we couldn't know how fast it's expanding now while it's there, because there is far from here. Why is the Earth a globe? Why is the Earth a globe? Because gravity. Gravity pulls things into spherical shapes. Hey, how do you define sitting still? Granted, I'm sitting here. I'm traveling really fast. You don't. Please explain how infinite past time came to our days. Oh, didn't we have a conversation about this earlier? What math level you reached in high school? I did Calc 3 senior year of high school. Is the end of the universe more likely to be a big crunch or a big rip scenario? It could be neither. We don't know. Why would it be neat that protons decay? Because it'd be some new physics that we would observe, and we would have something to get to put our teeth on, like to actually do some physics, some empirical data. How do we know that mass isn't attracting the mass from our observable universe rather than the Big Bang Theory? I have no idea what that question means. Is there a point of no intuition? My view is that if you work with something long enough, you will develop intuition for it. What is the level of math someone should have before they take a physics class? It depends on what physics class you're talking about. If you're talking about like a university calculus-based physics class, you should have calculus. Do you think everything eventually boils down to a single thing that manifests itself through different scales and gradients? Maybe. Why is energy not conserved at cosmological scales? Because the universe is expanding. Because the universe is expanding, there just is no global, it's called a time-like killing vector, and if you don't have a global time-like killing vector, then you don't have a well-defined energy. There's not a well-defined, I should say, a well-defined coordinate invariant notion of energy of the system. From PhiMaths with the $5. Hi, please help me spread the message that minus plus 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 is the better metric signature. It's true. Minus plus 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 is the better metric signature. If you think otherwise, then you are a lowly hack. Best place in Europe for PhD in mathematical physics? Probably Cambridge. Where can you buy tickets to see you, Justin and Ian? Go to the link on. So I posted on YouTube, on stories. I posted or on posts or whatever. I posted a website. If you go to peng-burn.com, you'll find it. Do we have any good ideas on why space-time is expanding and accelerating? Yeah, whatever dark energy is doing it. We don't know what that is, though. Do you have any good physics lectures on YouTube that you'd recommend? Mine, yeah. If you go to physics, I think it's like Physics Lectures 4649 or something. That's a YouTube channel that I started when I was a physics lecturer. And I put up, sorry, it's, let me pull it up. Yeah, Physics Lectures 4649. That's the username. It has a year's worth of physics lectures at the university level. So check it out. Can you get a job as a quant after MIT? I mean, I guess you could. It depends on whether or not you got hired, right? Like, oh. The universe is finite in size, meaning it must have edges. Well, first of all, we don't know if the universe is finite in size. Certainly the observable universe is finite in size, but that doesn't say anything about the whole universe. Secondly, a thing can be finite in size while still not having edges. Think of like the surface of the Earth. The surface of the Earth is finite, meaning that the surface area is finite. There's a finite amount of places that you can be, and yet it doesn't have any edges, unless you're a flat earther, I guess. Remember, if you're spamming, I will purposefully ignore your question. So please don't spam. What is your opinion of AI use in physics? It's going to be used. However you feel about AI, its environmental impacts, and I'm not talking about like specialized machine learning. I'm talking about LLMs. LLMs are going to be used. That's the reality. They are already being used. And they're being used, like there was a paper that I think Kumran Vafa was an author on, or maybe it was, who was it? It was like, there was a big name that published a paper using an LLM, right? They're going to be used. Do you believe in the principle of sufficient reason and free will? No and no. Probabilistic interpretations of quantum mechanics incompatible with the block universe? Not necessarily. What What's physics thing that simply doesn't mesh with lay people intuition? Anything about quantum mechanics, really. Have you considered doing a policy-centric debate prompt, perhaps in place of the MAGA science debate? No, well, okay, I mean, I used to do that. I just don't want to anymore. Can you please explain light cones and Hubble's research on other galaxies? So, okay, let me explain. A light cone is basically the places in space-time, so say the past light cone of something, are all of the places in space-time that light would have enough time to get to that point in space-time from. So, like, light can get to you, for example, if I go the light cone for, like, for me, that goes back in time, say 10 minutes, is exactly 10 light seconds or 10 light minutes away. That is the extent of the light cone, because light from anywhere within that distance would have had enough time to get to me. More specifically, that's actually the past of my space-time event. The light cone is really the boundary. In crunch bounce, are each universe random after expansion? It depends on the model. Are physics-related jobs lonely, or do you usually work in teams? I usually work in teams because I like working in teams, but you don't have to. What is the half-life of proton during its decay? We don't even know if protons do decay, so... How is publishing and writing papers different as someone who is self-employed independent? It's not that different, really. I haven't really had any issues. Physics LLM would just say multiverse repeatedly without end. I don't think it would. Can you speak on the Jacobian resolution by AI? Well, I don't know what the prompt was, but some guy prompted, like, it was either like Claude or ChatGPT or something like that, and got a resolution for the Jacobian conjecture. So that's something. What does AI do for physics? It can, so one thing that I found it's useful for is ruling out bad ideas. So if you have an idea, it used to be, before we had access to this tool, it used to be that you would spend like a week working out all of the consequences, and you know, trying all the different avenues, and then you'd say, oh, this is a bad idea, I guess I'm gonna abandon it. But LLMs, AIs more generally, are very, very good at finding inconsistencies in things. In fact, this is kind of expected given all of the mathematical progress that's been made using LLMs. Most of the things that have been figured out using LLMs are counterexamples. So AI is generally very good at that, and so it can show you why an idea is bad fairly quickly. And so you don't waste as much time on bad ideas, and you spend more time on good ideas. Singe, thank you for becoming a subscriber with Prime. I appreciate that. As a physicist, do you believe in God? I do not. I believe Joseph Smith proved God a long time ago and he was a scientist. I don't think Joseph Smith was a scientist. Wasn't he like a newspaper boy or something? Is there a good layman explanation for quantum tunneling? Not really. Essentially, I mean, what you can think of it as is you can just think of it as the wave function for a particle that couldn't otherwise get through some sort of barrier. It kind of just leaks through, because the wave function is very averse to suddenly changing. Takes a lot of energy and such for that to happen. So it's kind of cheaper energetically to leak through a barrier, and if the barrier is short enough, then it can leak through a little bit. Is there any work made in any physics field that targets behavior in Planck scale size and below? Yeah, plenty. Lots of like quantum gravity stuff. I got into BS mathematics in the #1 university here in my country. Is it worth it to pursue research? If you want to, you don't have to though. If I bang a neutron moving at a constant known speed into a backstop, why don't I know the position of momentum at that instant? Well, so at an instant, the thing is before you bang it into a backstop, you don't know its position of momentum exactly. So how will you know when it hits the backstop? Is there something called the rule of 7 in mathematics that can be demonstrated with a card trick? I'm not familiar with it. If we actually observe dark energy / matter, what would that change in the world? It would change our understanding of the way the world works. I think that's pretty big. Can you summarize how Leonard Susskind describes the way light travels? I don't know how Leonard Susskind describes the way light travels, so no. Is there a general field, or is everything relative? I don't understand what that means. Are mainstream academic physicists starting to pay more attention to UAP data now compared to past decades? Not that I know of. Cannot wrap my brain around nothing before the beginning. Well, good thing. Good thing I don't think that there was ever nothing. Angels of light destroyed you, Earth is flat. Oh, okay. Whatever you say, buddy. Whatever makes you feel good. Is a strong force more powerful than love? Yes. Could higher dimensionality explain things such as dark matter or dark energy? Maybe, and people have tried to do things with this, but they haven't been particularly successful. Are you familiar with how to derive attraction / repulsion between electric charge and QED? I worked through it once, like maybe, I don't know, like 10 years ago, and I haven't thought about it since, so I'd have to go back and like look at my notes. I'm gonna jump down to the bottom because I'm a bit behind, but if I missed your question, apologies. Would expansion of the universe eventually make the evidence of the Big Bang undetectable? It would, if it keeps expanding forever at the same rate. Time is relative. How do we get an objective age of the universe? So what we're talking about when we talk about the age of the universe is essentially how long it's been since the cosmic microwave background radiation. And so what we're really talking about is you pick a reference frame. So it is relative. We acknowledge it's relative, but we can still pick a reference frame. We pick a reference frame that is in some sense co-moving with the cosmic microwave background radiation, so it's stationary with respect to it. Meaning that the cosmic microwave background radiation looks like it is coming at you at the same temperature in all directions. Because the CMB is measured typically in temperature, and if you're moving in one direction relative to it, that direction that you're moving in will appear to be warmer, just because of the way relativity works. And so it's from that reference frame, where you're stationary with respect to the cosmic microwave background radiation, that you get 13.8 billion years or so. Are you married? Yes. How do we know the vacuum energy? If nothing can be zero, what are we comparing it to get the value? We don't. This is a personal gripe that I have. Do you believe in an eternal universe? Does that bother you? It doesn't bother me. I'm agnostic on it though. I have a bachelor's degree in mechanical engineering, but I want to pivot into theoretical physics. Is it possible for me to pursue a master's in physics, or do I have to have a bachelor's in physics? You could, but the question is are you going to get into grad school? And like, it's competitive, right? Non-scientist here, where did everything come from? Well, maybe it was always here. Hard to say. If the Big Bang explains the evolution of the universe, what explains the origin? It's not clear that there was an origin. Can electrons be observed under a microscope? Not traditionally, no. Atoms can be observed with scanning tunneling electron microscopes, though. If you're traveling in a circle, will space contraction happen in 2 directions? It just happens locally. If you're accelerating, though, like, it's not... So from your perspective, things in the direction of travel will look shorter. How does light know which path is the fastest when entering a new field? Well, look, we're anthropomorphizing it. It's not that it knows, it's just that there's equations, and those equations tell it how to move. Do you have any tips on learning physics going to learn it in my new school? Make sure your math is strong. So what exactly is spin, since atoms technically don't rotate? Spin is a fundamental property of matter in the same way that mass, in the same way that charge is. From Garain with the $10. Thank you so much, Garain. Here's $10. Please go more in depth on your gripe with vacuum energy value. Yeah, so there's kind of two things that are happening here. So the first thing is that we talk about the there's vacuum energy in quantum field theory. Vacuum energy in quantum field theory is just a relative value. You can add a constant or subtract a constant from any energy in quantum field theory and nothing will change. Has absolutely no effect. However, the vacuum energy in general relativity does have an effect. The absolute value of the vacuum energy has a very, very important effect. If you have zero vacuum energy, then it doesn't gravitate. If you have non-zero vacuum energy, it does gravitate. And so the point is as far as I can tell, we don't have any knowledge about what the actual vacuum energy from QFT is, because QFT doesn't tell us what the actual vacuum energy is. It only gives us a relative vacuum energy. So, that's my gripe. Do you think Eric Weinstein is a hack? Have you looked at geometric unity? Yes and yes. Are the longest solar eclipses observed in the northern hemisphere? I don't know. Maybe. I've never heard that claim. What does it mean to say that the fundamental interactions were unified at the moment of the Big Bang? Well, so think of it like this. So yeah, how do I want to describe this? Okay, yeah, so here's one way to think about this. So imagine that you had like blended a mixture of water and ice, or of water and oil rather. You blended this mixture and then you froze it while it was still blended. But like, yeah, so it's frozen, and so you just have like little pockets of like little microscopic pockets of oil and little microscopic pockets of ice water, or of ice, frozen, and all mixed together. But as it melts, the water and the oil will start to separate. Assuming that they have the same, like, you have to assume that they have the same melting temperature for this analogy to work. And so the idea is somewhat similar for kind of the fundamental interactions being unified near the Big Bang, namely that like the temperature was so hot that they hadn't kind of separated out yet. And this kind of thing makes sense because the strengths of the forces change with temperature. In particular, as your temperature goes up, the strong nuclear force, or the quantum chromodynamics, gets weaker, electromagnetism gets stronger, and so like one could imagine that there's like a middle point where they all kind of match up and they all kind of behave the same way. And that's only true at high temperatures in the very early universe. That's roughly the idea. Also, we have a lot of flat earthers in here spamming today. Is the wall we are hitting in physics experimentation seemingly due to engineering issues? We know what to test, but it's really hard to do so, or do we just not really know what to experiment? So for the straightforward experimentation issues that we're running into, these are engineering issues. Now, it could be that there's a clever way to do physics experiments that would not involve engineering issues, but we don't know how to do those. 12 Afonso, thank you for joining with Prime. Thank you for subscribing on Twitch with Prime. I appreciate that. You taking guests? Not yet. Flat Earther. Oh, flat Earthers only show up when they don't have to debate Blitz. True. Kitty, what's wrong? Does Phobos speed up the orbit of Mars around the sun? I don't see why it would. Do you think the universe exists outside of what is observable? Well, sure, yeah. Do you know OEIS? I do. I really enjoy OEIS. Online Encyclopedia of Integer Sequences. How familiar are you with signals and systems? Not very. What interpretation of a physics theory online or immediate or intermediate bothers you the most? Online or intermediate? I don't know what that means. When they're wrong. That's when it bothers me the most. Do you eat burgers without or with or without pickles? It depends on my mood. Are you actively teaching at any university? Do you have any grad students? No and no. From Lost in FRP with the 220 Turkish lira, any possibility of a non-spinning black hole? Thanks. Very, very slim. Like, it's in principle possible, but it's very, very slim. What are the odds that there exists a planet in our galaxy that we can breathe the air and drink the water? Breathing the air would be harder than finding water to drink because water is very common. Oxygen as a free molecule is not very common at all. Was I banned on your Twitch chat? I don't think so. At least I didn't do anything, but... What's one thing, no matter how many times you think about it, you cannot wrap your head around? It's gotta be BGG sequences. They're my nemesis. What do you think about time being a fundamental operator in logic, like a consequence of writing or recording symbol? I don't know what that means. It's hard for me to have an opinion on it if I don't know what it means. Can you explain why it's hard to find a planet that we can breathe the air? This is more of a chemistry question, but pure oxygen, like the oxygen molecule O2, is really, really reactive. Like, it just wants to, like, if there's iron around, that iron will just react with the oxygen and form rust, and then there won't be oxygen, right? It just wants to react with just about everything. Why do oxygen molecules always come in pairs? I guess that's just the stable molecular configuration. I don't know, ask a chemist. Will Dyson spheres be humanly possible in the future? Maybe. Could space-time be the gauge field of gravity? People have talked about this, yeah. But it's not a gauge field, right? Because it's not a compact Lie algebra, but, or, you know, S to 3-1 is not a compact Lie algebra, but maybe. Is Einstein's state that past and future exists, like, literally physical timeline? I don't know what that means. What concrete steps to take during grad school to maximize employment and research after graduation? Publish a lot. Publish well, in good journals, and also go to conferences and meet people. Why can't general relativity and quantum mechanics be unified? Because the methods that we typically use to take a classical theory and make it quantum don't work. And they provably don't work. Like, you can prove that there's no way to make them work mathematically. Why can't general... Oh, I already answered that. Does the galaxy follow an orbit path, or is it random chaos? Or what dictates our galaxy's path? Oh, the galaxy moves in the same way that all things in the cosmos move. It moves under the influence of gravity. Can you see gravity? Yeah. Super easy. Why am I not getting pulled towards the giant football stadium if everything has gravitational pull? Well, I mean, in principle, you're getting pulled by everything, but the thing is that most things are far too small to have any noticeable effect. Don't we have a material problem for Dyson spheres? Well, no, I mean, we could mine asteroids. Why did you ban my question? I don't even know what your question is. Why do we need a physics formula that deals with relativity and quantum mechanics? Well, not that we need it, but it's very strange that we don't have it, because there are places where such a formula would be the only thing that would give us the right answer as to how the world works. Like black holes. Dr. Blitz, can you explain general covariance? General covariance is just the idea that the physically observable quantities should be independent of the coordinates that you use to label or describe those observable quantities. Is there a reason to think the universe admits more than one physically realizable vacuum state? I haven't thought about it. I don't see why you couldn't have more than one physically realizable vacuum state, but one of them would be metastable, right? I was flamed today on Ask Physics for asking if turned into a photon, how would I experience time? Sorry. Well, you wouldn't experience time, but you also can't turn into a photon. But also, you wouldn't experience anything. Like, this is not a... It's an ill-posed question, it turns out. What do you think of the theory by Carlo Rovelli that presents time as a consequence of entropy rather than something fundamental? So I don't know what Rovelli's position is, but generally the position is that the direction of time is a consequence of entropy, the apparent direction of time, rather than time itself. Doesn't Maxwell bivector sound cooler than electromagnetic tensor? Yes, it does. Is there an upper limit of the number of protons in an atom before it falls apart? Yeah, it's gonna be like... That upper limit will be below 1,000 protons. Surely. Is there any reason to think... Oh, I already answered that. Again, guys, please don't spam. Oh. How do quarks have energy? Where do they get it from? The same place anything gets it from fields that they interact with. Is the entire universe in a black hole? Is that why everything on the periphery seems to be expanding? No, at least I don't think that we have really any good evidence that the universe is in a black hole. What do you think about the idea of warp drives, and do you think it'll be operational? No, I suspect it won't be. And I suspect it won't be because essentially they require, as far as we can tell, a kind of matter that just doesn't exist. What exactly is cold fusion and how does it differ from hot fusion? Excellent question, by the way. So cold fusion was this idea in the 70s that you could somehow catalyze to otherwise not particularly hot, not particularly high pressure, say hydrogen atoms or deuterium nuclei to fuse to form helium, and this would give off energy. And the reason why cold fusion would have been so nice is because it's just really hard to get, and let me distinguish this from hot fusion. Hot fusion is when you get a gas, when you get hydrogen or deuterium or whatever hot enough and high enough pressure that the nuclei are forced to be so close together that they inevitably fuse and they give off a little bit of energy. The thing is it's very, very challenging to maintain or to produce and maintain that high pressure, high temperature environment. So it'd be really nice to have some sort of cold fusion that doesn't require all of the difficulty that we go through to do hot fusion these days. But unfortunately, it was shown to be a fraud in like the, late 20th century. It's not a real thing that's achievable. Except muon catalyzed cold fusion, which is achievable, but is not particularly practical. Is it common for an idea to sound good just to be destroyed by the math and physics? Yes. Is the photon's observation during its lifespan instantaneous as it travels physically from its start to its end? This is not a question that has an answer in physics, because it's not it's not a well-posed question. There is no such thing as a photon's observation, not even like metaphorically. There's no reference frame that a photon has. No valid reference frame. At night, you can't stare directly at headlights, but you can during the day. Why? Oh, it's just because of your eyes adapting. Can there be undiscovered stable elements which we don't have in our periodic table? Maybe these would be lying in the island of stability. They'd be very, very heavy elements that that don't form naturally, or if they do form naturally, they're very, very, very rare. And they would be more stable than, similarly heavy elements. Oh, sorry. Why do we see hot and cold spots in the CMB? These are quantum fluctuations. Space-time is emergent from a deeper phase geometry. You're welcome for theory of everything. This is not an original thought phase, bro. Why is spin one half? One half of what? Or 2 for graviton? It's just one. So the units of spin are in units of h bar. So spin 1 means 1 unit of angular momentum. Spin 2 means 2 units of angular momentum. Sorry, means 2 h bar units of angular momentum. It's just an amount of angular momentum in terms of h bar. Is methods of symplectic geometry used in GR? Yeah, to an extent. To jump down to the bottom. By the way, if you guys want to guarantee that your question gets answered, the best way to do it is to send a super chat, because then it prioritizes it in my queue. Otherwise, I might miss it. What is the formula for work done? It's the integral of force applied over a distance. In the direction of travel, of course. Can you explain how quantum mechanics doesn't work in macro scale? I don't understand. I mean, it does. It just looks classical at the macroscopic scale. Can I pursue in PhD theoretical physics without masters? I'm only an undergraduate physics. Well, you could apply, but you might have a hard time getting in. If you can get in, then you can do it. Explain the cosmological constant problem. Yeah, so I do have a video on this, but the cosmological constant problem is essentially that the observed cosmological constant is like way smaller than any reasonable person would have put it. It's like if you were going to guess the cosmological constant, it's like a few dozen to over 100 orders of magnitude smaller than you might think it would be. And that's a problem. That's the issue. You left out work with a dot product. The force applied in the direction of travel is the dot product. What theory of dark matter do you subscribe to and why? I don't have an opinion on it because it's not my area. Sorry, my lips are super dry. From Ted K with the $5. Thank you so much, Ted. Can you explain the way that Einstein's metric tensors or in his gravitational field equation connect with one another? The way that they connect with each other? There's not multiple metric tensors. So the Einstein field equations, this is the gravitational field equation that you're referring to. This connects the curvature of a space-time metric to in particular, the trace-adjusted Ricci curvature, to the stress-energy tensor, which tells you basically about how much mass and matter and energy and all that stuff is around. And it just says that the trace-corrected Ricci tensor is proportional to that stress-energy tensor. Dark energy and dark matter are coping mechanisms. Say that again when you get a PhD in the subject. That's just what people who don't know what they're talking about say. Why do scientists support flat earth theory when politics is involved? They don't. How long can you do research before being forced into administration? It depends on your situation. What are your thoughts on entanglement emergent spacetime through a mereological phase transition? I think it's an interesting idea. I like it. I don't have any proof of it, but I like it. What do you think about category theory? I'm afraid of it. If the universe was inside a supermassive black hole, wouldn't redshift only be visible in one direction? Kind of, yeah. Do you have any advice for clear, concise science communication? No, I don't even know. No, I don't know. I just say things. Maybe I've just taught long enough that it just comes intuitively to me, but I don't have any good advice. No, I don't think so. Which I know that that's not helpful, but sorry. Who's your favorite living physicist and why? Roger Penrose, and just because he's done some amazing things. From Austin, or from Augustin Alkoshi with the $5. Thoughts on Yu Dang's Fields Medal? I didn't really follow the Fields Medal stuff, so I don't really have opinions on it, sorry. It went to like algebraic geometers, and that's just not an area that I'm interested in. Can you derive the Bogoliubov, it's Bogoliubov coefficients for an entangled Hawking pair on the horizon references? Well, if you mean can you, as in like, is it possible? Yes, of course. I think even Hawking did this in his original paper from 1975, I want to say. Can I do it off the top of my head? No. I never got into QFT in curved spacetime, so I just don't like. I can kind of muddle my way through it with references and like follow along, but like I couldn't do it myself off the top of my head. Because the universe is expanding faster than the speed of light, will the age of the universe in future? Well, the universe isn't expanding faster than the speed of light. The universe's expansion rate isn't a speed, right? It's a rate. Not all rates are speeds. Does the answer chats here or on TikTok? Both. How important is energy conservation and time symmetry for quantum theories and quantum gravity? I've been working through discrete Lagrangian for fun, and so there's no time symmetry, which sucks. Yes, it is pretty important, and it means that you'll have a hard time defining things like ground states if you don't have a time symmetry. And I ran into this into a paper that I wrote, like in a paper that I wrote a few years ago or last year or something like this. And you have to work really hard to make sense of things like ground states. What do you do in condensed matter research? You research condensed matter systems. Condensed matter research is very close to material science. It's more physicsy, of course, but it's very much like, you know, physics of like bizarre phases of matter at like low temperatures, or you know, superconducting things, or topological quantum states, these kinds of things. Why do you wear glasses? Because my eyes suck. How fast would the Earth have to spin to neutralize gravity at the equator? Well, so gravity, or so the acceleration scales as like the rotational velocity squared, and the current value is something like 0.1%. So it would have to spin like 33 times faster, I think. No, I'm sorry, it's not 0.1%. It's like 0.1 centimeters per second squared, right? Okay, actually, we can work this out. So a million miles, what is a million miles in kilometers? No, actually, we can just do 24 hours, one rotation, 24 hours. So an angular speed is 2 pi over 24 per hour. I would have to pull out a calculator if I actually wanted to do this properly, because the numbers are not nice and round. But yeah, there is a speed that we, okay, I'll just go look up what the centripetal acceleration is. Acceleration at equator. Okay, the centripetal acceleration at the equator is 0.0337 meters per second. So this is something like 1 over, so if it was 100 times bigger, it'd be 3. So it's like 1/300th of the acceleration of the acceleration due to gravity. So if you wanted to cancel them out, you need to take the square root of that, and it would have to spin that much faster. So it's something, it would have to spin something like 17 times faster, I guess. So you're saying the universe is expanding faster than the speed of light, but the speed is increasing at a certain rate, or am I misunderstanding? No, the universe's expansion speed is not a speed in the sense of distance over time. It can't be compared to the speed of light. What is the case is that the universe has a doubling time. It, like, you know, for a given volume of universe doubles in size every certain amount of time. But the speed at which the distance between the two edges of that volume depends on how big that volume was to begin with. So at the current rate, the universe expands at a rate of around, it doubles in size roughly every 10 billion years or so. Takes a bit, but he takes a bit, but chat is slow, so he always responds. Yeah, I have to first see the Twitch messages, but yeah, so I try, but is your knowledge of physics reconcilable with belief in free will? If so, what would the locus of agential actuation be, and how would one's consciousness materially affect the movement of particles? Okay, no, it's not reconcilable with free will. I don't think that free will exists. Do you watch Dr. Proton on TikTok? No, although I've heard that he might not be a real doctor. Somebody messaged me about this. I don't actually know if wait, somebody just tagged me in something? Sorry. Oh, okay. Sorry. Okay. Yeah, so Dr. Proton might not be a real scientist. Somebody told me that. I saw his live last night, but didn't go into it. I'm loyal to one physicist. Well, I appreciate that. I don't know if he's a physicist. I'm going to talk to him. I'm going to quiz him at some point. Is the universe a collapsed wave function? Maybe. If we think of the resolution of the universe, do you think quarks are already the pixels? No. And it's not clear that there is a resolution to the universe. I picked up the big orange book, the astrophysics textbook by Osley and Bradley. Any other book recs? Depends on what you're interested in, right? If our home is round, why is my desk flat? Because you built it. It was built flat. Any new news on the notion that the rate of acceleration of expansion may be decreasing? It is still being worked on. What is the purpose of the Antarctic Treaty? To preserve scientific research capability there. Did you know that in the 19th century, physicists didn't know there was a connection between the magnetic field and the electric field? Yes, I did know that. Yeah. You think the universe is infinite and has all the infinite possibilities? Maybe. I could go either way. I would actually kind of prefer that it's finite because the physics is nicer, but it could go either way. Is the Planck length a unit of space or a limit of our theories? It's neither. It's just a fundamental distance scale for certain physics to be relevant, seemingly. Yu Dang solved Hilbert's sixth problem, which showed that macroscopic fluid equations follow from microscopic. Oh, wait a minute. Actually, maybe I may have actually even seen this article. I thought you were talking about somebody else. I actually may have seen this article. His work. Actually, and so in his case, yeah, it is really neat. Why have the Pringles not returned? Okay, let's go find out if Pringles are gluten-free. Pringles are not gluten-free. That's why the Pringles have not returned. In broad terms, how does your expertise in the field of physics inform your approach to philosophy? That I tend to have bias or give preference to things that we can verify using our senses and using experimental equipment. Why is there a belief that we are creating math and not simply discovering it? It's because it's pretty, like, when you actually do math, you just make stuff up. You create it to do what you want it to do. What are the implications of the ADS CFT in traditional de Sitter spaces? This is an area of intense research. People are trying to do DS CFT correspondences, and it's very hard because you don't have a time direction, so you need to somehow get emergent time, and that's tricky. Philosophically, if the universe were infinite, there would be a part of the universe that would cancel the entire universe. I don't know what you mean by cancel. 12 Afonso sent 10 bits. I don't know what that is, but how do you see 4D? Do you think 4D beings would see you as a shape from the moment you were born to the moment you die, or more spatially 4D? So look, if there are beings that are four-dimensional in the sense that we're three-dimensional, then that would mean that they live in a five-dimensional space-time. So they wouldn't see our time as space for them. They would see it as time. And so they would just see us as like, in the same way that we would see like little things on a sheet of paper moving around, they would see us like that. Why was string theory promoted so strongly in the 80s? Because it was really, really promising. Do you think that one day black hole singularities would be understood? Yeah, and I think that they won't be singularities. Sorry, chat is moving a little bit too fast. Do you think that everything that is a thing came from nothing? No, I don't think that nothing ever existed. What are the laws of physics mathematically? Why are the laws of physics mathematically elegant instead of arbitrarily complicated? That's a philosophy question. What are the most relevant results of string theory research? You'd have to ask a string theorist. I'm not a string theorist. Why are the laws of physics? Oh, you already answered that. What are your thoughts on Lorentzian ether theory? I haven't heard of it. From Ted K with the $10. Thank you so much, Ted. Thanks for answering my question. I was wondering if you have ever heard of an engineering graduate becoming a physicist later in life. I'm studying engineering right now and hope to go into aerospace. Sort of, yeah. So I have a friend slash colleague who got his undergrad in mechanical or electrical engineering, I think, and then he went to grad school for string theory. And now he works as a scientist, as a physicist at a university. From the Real Vesticles with the $2. Hey Blitz, what's your greatest accomplishment? My greatest accomplishment is somehow convincing my wife to marry me. And to also like me. Probably the second one's harder than the first one. Once she liked me, it wasn't as hard to get her to marry me, but you know. Do you think any theory before CMB last scattering is BS? No? Oh, and I have answered your question now 3 times. Are timelines collapsing into one? There probably aren't extra timelines. From Grimmy with the $2. No Pringles? Try the good crisp. Okay, maybe I will. Maybe I will. What even is string theory? String theory is a proposed, essentially, theory of everything, which is supposed to explain certain features of our world better than standard quantum field theory does. Namely, it's supposed to account for gravity, it's supposed to account for various problems that you run into at very, very high energies in quantum field theory, and so on. And it does this by basically positing that instead of having tiny point-like particles in fields, you instead have everything being composed of tiny little strings. And those strings evolve in certain ways, and they give rise to particle-like behavior. Did you do a presentation for APEC? I don't know what APEC is. Where do you stand on the anthropic principle? It's useful for some things if you have like a large sample size. Blitz 10 Twitch bits means 10 cents USD. Okay, well, I'll keep that in mind. Who do you think was the greatest physicist to ever live? Einstein, and then slightly behind is Newton. Do you have thoughts on the BGV theorem? I do have thoughts on the BGV. Oh, I should take this way. I do have thoughts on the BGV theorem. The thoughts on the BGV theorem are, it's not a theorem. It has counterexamples. Who do you think was the... Oh, okay, I already answered that. You've been so focused on asking that you forgot to listen. Shame, Owen. Shame. Do you think topology is important in higher education? I mean, if you're interested in mathematics, yeah. Question, Dr. Blitz, what do you think of gravitons? They probably exist in some respect. What is the strongest piece of evidence that space-time is fundamental rather than emergent? I don't think that there is any. This is like an open question, so I don't think that we have any evidence one way or the other. Can mathematical consistency and theorems replace sometimes the experiments method? Yes, as long as you can use experiment to justify the hypotheses and you can prove something mathematically true, then I think that is okay, yeah. Doesn't 10 dimensions sort of imply branching timelines, though? No, the 10 dimensions of space-time, which, you know, that's a string theory thing, which we don't really have reason, at least I don't think that we have particularly compelling reason to think is actually true. These are just 9 spatial dimensions and 1 time dimension. All right, so it is 11, so I'm going to switch on over to live, or to subscriber mode only. Everybody can watch, but only members, subscribers, and so on can send comments. I will also be bringing up guests to ask questions in person, so you won't be left out even if you wanted to ask a question and you can't. So because I will be bringing up guests, but in order to do that, I need to restart the TikTok live stream. So when I do that, make sure to come back immediately, and then I will start taking guests and start answering more questions. So give me just one moment, everybody. I'm going to reset the live stream on TikTok, and we'll be right back. If gravity is just curved space-time, why do we still talk about gravitons and try to quantize it like a force? Well, look, electromagnetism is just a curved U1 principal gauge bundle, but we still talk about photons and we try to quantize it like a force. All of the fundamental forces are curvatures. They're just curvatures of different things. Welcome back. Welcome back. Remember, if you want to ask your questions, they are basically guaranteed to get answered now, as long as you are a superfan or a member or a subscriber, depending on what platform you're watching on. If you just want to send it in text. If you would rather ask a question, and of course I will prioritize super chats if you want to help support me that way, but I will also be bringing up guests to ask questions as well. Keep in mind, if you do become a member or a superfan or whatever it is, it's like $5 a month. And you get a string of perks. So you get access to a private Discord channel, you get access to these live streams, you get access to my personal debate notes that I use when I'm doing these debates, and where I put my sources and my arguments and so on like that. And then you also get access to emojis, depending on where your emojis in the relevant social media where you choose to subscribe. So consider doing that. It's a great way to support me if you want to. And otherwise, let's get the party started, shall we? Does Twitch have access to debate notes now? You should. No, well, okay, so no, there's still an issue with it happening automatically, but you should have access to the Discord channel. And if you have access to the Discord channel, in the private Discord channel, the debate notes are pinned there. How's the gluten-free adventure going? It's a process for sure. I'm not having fun with it, I'll tell you that much. Maybe your real problem is global fool disease. I don't know what that means, but that's fun. Hey, Dr. Blitz, thoughts on the possibility of a microcosm? I don't know what that is. Is this like a reference to Men in Black? Yeah, I don't know. I feel like you would have to give me some more more details. Also, Patreon is the best way to support Dr. Blitz for consistent support. That's true. Patreon is also a great way to do it. It's just you get one fewer perk, namely you don't get questions answered here. How does it feel to lose to Deathless Light during Ask a Physicist? It was crazy. All right, let's bring up Dr. Jace.
Oh my gosh, hey Blitz, how's it going?
Going all right. Dr. Jace, what questions you got for me?
Okay, so not a physicist. I'm actually a neuroscientist. So,
Sure.
but I would sit around and I when I get bored, I dabble in physics mentally and just to keep myself challenged. And I was thinking about hypernovas the other day and how the path to infinity works. So, would you
What path to
agree
infinity?
that, like, for how light travels?
Oh, okay.
Yeah. So I was thinking with the way the brain works, as long as it's a healthy living brain, it supplies its own path to infinity because you can infinitely divide by 2 or draw a star within a star. So your brain just has that capacity to just continually do the same thing over and over and over and over again.
Sure, it could, at least until it dies, but sure.
Yeah. So taking that into account and making the observer here on Earth viewing, say, a hypernova at the edge of our observable universe.
Sure.
Okay, so if that hypernova, when it ejects a gamma blast in the opposite direction from the observer, at the local law, would the gamma blast would be traveling at sea, correct?
Yep.
Okay, so but relative to the observer, because of space-time expansion, it would move faster than the speed of light relative to the observer.
So we always, so sort of, but it's hard. This is not something that like it's okay. Let me back up. So when we talk about when we start worrying about like curved spacetimes, which expanding universes are like ours, it becomes very, very difficult, if not literally mathematically impossible, to define what a speed is in a non-arbitrary way. If you're talking about something that is, say, sufficiently far away from you, if you're talking about like something moving but also being far away from you, you can only really invariantly characterize the speed of something when it's right next to you, or if the space-time curvature is small. And so because we're talking about something at the edge of the observable universe, like this hypothetical hypernova, it's just not even a well-defined question to ask how fast it's moving relative to us, because it's just not like a well-defined notion in curved spacetimes.
Okay. Then my second question would be, if there were a hypernova diametrically opposed to the first one, they would be moving relative to one another at 2c?
Again, you can't compare speeds unless the things are right next to each other. That's the problem.
Oh, they have to be right next to one another.
Yeah,
then.
Or there has to be no curvature. But because they're very far away from each other, they're like, 96 billion or 93 billion light years away from each other. These speeds are just not comparable.
Okay. And so when we observe time dilation under those circumstances, we're looking at it relative as the observer. You can't really apply the ideas of like time travel and things like that with regard to the particle ejection.
No.
Thank you very much. That is exactly my question, and that was where my brain was headed, but I wanted to make sure that I was thinking about it in the right way.
Sounds good. Well, thanks for the question, man. Have a good one.
You too.
All right, let's read some more not super chats, questions, and then we'll move on to another guest. A microcosm is a miniature version of a larger whole. Whether this whole is okay, so some believe it's possible within a hidden range of movement. Yeah, so I mean, microcosms do exist, like small ecosystems or whatever, but I don't think that our universe is like a microcosm, if that's what you're asking. All right, let's bring up L. Matthew Red. L.
Yo.
Matthew Red, how's it going? Is this the Matthew Davids, also known as Matthew Theorem? Okay, yeah, what you got for me?
I just want to ask a question really quick.
Sure.
I looked at that Lesnevsky paper, and it says that it violates energy conditions. No energy conditions in abstract, yes or no?
I don't know off the top of my head, I don't remember.
Okay, is the BGV theorem purely kinematic?
Sure.
Is it purely geometric?
The theorem, sure. Yeah, it's actually not really purely geometric. It's kind of reference frame dependent. It's reference frame dependent, so it's not purely geometric. No.
How do we derive it?
How do you derive the BG? Well, it's not a theorem, so you can't really derive it.
The geometry.
What are you asking me?
For the BGV theorem, how do we derive the geometry?
The geometry of what?
Space-time?
The space-time is given.
How do we derive the space-time geometry of the BGV theorem?
The BGV theorem, quote-unquote theorem, does not derive the space-time.
The geometry?
Yeah, it doesn't derive the geometry. The geometry is a given.
Okay, so space-time. Nope. There you go. What is general relativity, sir?
General relativity is
Are you high?
Look, today's not a debate day. You can either cool your jets, you can ask questions, or you can come back on a debate day.
I asked you a question. Are you high?
Okay, well, that's a good way to get kicked off the charitable Ask a Physicist live stream. I brought you up because I assumed that you wanted to actually, in good faith, ask questions and increase your understanding, not just be a jackass. But you decided to be a jackass, so you lost your chances. Sorry. I know he was going to try to debate me, but I thought that maybe he would have some composure. You also can't just naively add velocities and relativity without gamma factor. That's true. Very true. It's also purely classical. Quantum effects or emergent space-time are ignored. True. That's also true. Sorry, not sorry. Yeah. Does switch of access? Oh, okay. Loud, annoying, and wrong. Yep. Very descriptive of Matthew. Let's bring up another guest, Derek, instead. By the way, you can also join through the Discord URL that's behind me. Derek, how's it going?
Doing well, going well yourself. I always wanted to ask this question, and I feel like I've never gotten like a clear answer.
Sure, I'll do my best.
Nothing can travel faster than the speed of light.
Yep.
Like when you're in a car going like 60 miles an hour, if I'm inside the car and move my hand, I can go like 61 miles an hour.
Yep.
Why couldn't you theoretically like blast a tube going like almost the speed of light, and then something inside that tube faster than the speed of light?
So the thing inside the tube relative to the tube itself. So okay, so let's say that you have a let's do the traditional thing that Einstein did. Let's say you have a train that's moving at like 95% the speed of light, right? And you're inside the train. Now, if you if you fire your ray gun and it shoots out a plasma bolt, and the plasma bolt moves forward at say 95% the speed of light, well then you might naively say, well, from somebody on the ground, somebody who's not in the train, they would see the plasma bolt moving at whatever 0.9 or 0.95 plus 0.95 is. So I guess they would see it moving at 1.9 times the speed of light. That's roughly what you're asking. Why can't you do that?
Yeah.
It's because even if you see the plasma bolt moving at 95% the speed of light,
and
that doesn't.
Am I the person standing
You're the
on
person.
ground?
No, you're the person in the train.
Okay.
And so you see it relative to the train. You see the plasma bolt from your perspective. It's moving at 95% the speed of light. But from the perspective of the person on the ground, the plasma bolt is only moving ever so slightly faster than the train. And so you might say, well, how does that work? Well, it's because your perception of time and your perception of space are different, depending on whether you're on the train or whether you're on the ground. And there's no one person that's right. It's just you have different relative perspectives. But in neither case, go ahead.
I was like, why wouldn't, I guess, say if like it was 95 and 95, why wouldn't the person on the ground see that thing like shooting like super fast? And the train,
it would move like 99% the speed of light or something. We could work out the details and figure out exactly what percentage. But the point is that velocities don't add like that. They don't add at in the way that you kind of expect them to at low speeds.
At low speeds or at high speeds?
So we expect velocities to add in like the normal way at low speeds, where you just add the numbers together. They just don't do that at high speeds.
Why is that?
It's because of the geometry and it's because of the geometry of space-time and the relationship between space and time. It's a little bit complicated, and you can work out the details mathematically. And if you go and you test this, like you run experiments, the mathematics agrees with the experimental results. It is essentially just a consequence of the fact that the speed of light is the universal speed limit, that there exists a universal speed limit. If there wasn't a universal speed limit, then the velocities would always add in the nice way. But there is a universal speed limit, so they don't add in the nice way. And that's just a fact of nature.
Is it kind of just like a limit where it gets like theoretically less and less fast the more you get closer to the speed of light?
Yeah, so Chase did the math for us, and 95% the speed of light relativistically added to 95% the speed of light gets you to 99.87% the speed of light. This is one of those things you could ask why, and I could give you tons of thought experiments that would demonstrate this. And we could see why, for example, your perception of time changes depending on how fast you're moving. You could see why, for example, your perception of space changes, or your measurements of space change depending on how fast you're moving. These will help build your intuition. And if you want to see more, if you want to see like these kinds of things in detail, you should look up Einstein's light clock train thought experiment or something. Basically, you can build a clock out of just light, and if all you do is assume that light always travels at the speed of light, then you can show that time has to tick more slowly if you're moving quickly. And of course, if time ticks more slowly, then what you might think is 95% the speed of light might actually be much slower for somebody else, for example. So it's a whole conflation of things that always, it's almost like a conspiracy. They conspire so that nobody ever sees anything moving faster than light, which is interesting, I think.
Yeah. Anyways, that's all I had. I'd appreciate kind of the explanation and stuff too.
Of course. Yeah, take care, Derek.
Yep.
We have a lot of people who shared the lives. Thank you guys for sharing the lives. What does the neutrino mass tell us about physics beyond the standard model? Well, currently neutrino masses cannot be accounted for with the standard model. That's the problem. So there is something beyond the standard model, or we're wrong about neutrino masses, which we're not. Oh, muted still. Okay. Scrolling through the chat. Okay, let's bring up AJB. AJB, how's it going?
I'm good. Can you hear me?
Yeah, I can. What questions you got for me?
My questions were going to be a little bit more like career oriented. So I don't
Sure,
really know
that's
if these
fine.
could be like answered, but I'm going to college for physics, and I just kind of wanted to ask, like, from like undergrad to like potentially like master's and then PhD, like, how do your opportunities expand between each degree? And like, is there one that just kind of like isn't worth it, or do you kind of need to go all the way to get like a good degree in physics?
Well, okay, so it depends on what you want to do. If you want to work in industry, usually it'll be enough to stop at a master's. Because if you're working in industry in the private sector, you're usually not doing physics anyway. You're not doing physics research. You'd be working more like an engineer that happens to know how to do physics than like a physicist. Than like a physicist doing physics research. If you want to do research, of course you need a PhD. If you're going to do just a physics bachelor's degree, then, I mean, you can. I know plenty of people who have done it, but you should make sure that you also pick up some programming skills or engineering skills or maybe financial skills or something, just so that you are employable, because generally physics bachelor's degrees there's not really an industry that wants physics bachelor's degrees, except that physics bachelor's degrees kind of just indicate that you're smart. But they'd rather have somebody who's smart and also that they don't have to train very much. So
That makes sense.
So generally, your opportunities go up as you get to a master's and then a PhD. But so your opportunities to do physics goes up, but your ability and the time that you have to do other things goes down. So, as you do a master's and a PhD, you're specializing more and more, and you're spending more of your life doing those things when you could have instead been, learning some aspect of some industry that you could then become well versed in and get a good job in that way. So it really depends on what you want to do. If your goal is just like get a good job, honestly, I would just do like engineering physics, which is a subspecialty of physics generally. Because then you can go get a degree go work as an engineer somewhere, or you could still go get a master's in physics, and then you could go take that and go work in industry pretty effectively. If your goal is to do physics genuinely, though, you need a PhD.
Makes sense. Like, I guess when going into a PhD program, and this might be more like school dependent than you could answer, but like if you have like an acceptance to one of these PhD programs lined up, does that really ever guarantee any opportunities beyond that research? And does that like research set you up for a future career, or is it more of like a risky approach that your research needs to be quality and then you can continue doing projects from there, assuming your first one is good?
Yeah, no, it's okay. So it depends. So what is essentially guaranteed is that they will, depending on the school, of course, they will essentially guarantee that, you know, they will provide a means for you to get funding for some number of years, right? So usually, if you're in the United States, you apply for a PhD program straight out of undergrad. You don't apply for master's programs in the middle. And they say, okay, we will bring you on for a throughput PhD program, and then for the first year or two, you will take classes as if you were doing a master's degree. You won't end up writing a thesis because you're going to write a thesis for your PhD anyway, but you'll take classes, you'll earn a master's degree, or you'll take classes, you'll take a test, like either an oral examination or some sort of qualifying examination or whatever. And then you'll be handed a master's degree just kind of willy-nilly, and then you'll ascend to candidacy. You'll become a PhD candidate. Once you've done that, then there's usually some sort of expectation or guarantee, depending on the school, that they will fund you for at least 3 years, say, or at least 5 years, or depending on however you negotiated. And so either that'll come from the professor that you're working with because they have funding, which they sometimes do, or the university will say, we promise that we will give you TA positions for 3 years or 4 years or however long, so that you have time to finish your PhD so you don't have to starve. Now, often that guarantee is only 3 years, and then they kind of just assume that either you'll be done 3 years after your master's, or you will be able to get funding some other way. But I haven't heard of many universities letting their students just not have any funding, and then they have to drop out. Like, it does happen occasionally, but it's not very common. So typically you're not guaranteed, but you can be pretty sure that if you get accepted into a PhD program and you're not a slacker, that you will have the funding to finish the degree. You might have to do some TAing, but you will have you can, as long as it's like a reasonable school and not like some like school that's just trying to scam you out of money or something, you can bet that you'll have the funding.
Okay. Thank you. I guess just like one more thing, kind of just out of curiosity, which quantum interpretation do you like personally kind of buy into?
I buy into the many worlds interpretation, but that's because I'm a Sean Carroll stan.
If you like, because my professor in high school was also kind of like for the many worlds interpretation, like what literature or authors do you recommend reading to kind of like
Sean Carroll and David Deutsch. Sean Carroll wrote a great book called Something Deeply Hidden, which is probably the thing that convinced me, to be honest.
Sorry, what? Something can be hidden?
Something deeply hidden.
Oh, something deeply hidden.
It's a lay level. It's like a lay level. I mean, it's, you know, it's not like any Joe Schmo off the street could read it, but like if you're interested in physics, if you have like something, you don't have to have any like math knowledge or anything like that. But if you're interested in physics, then it should be easily readable.
Okay. Yeah. Thank you so much. Have a nice day.
Of course, and good luck. All right, let's read some more chats. Chase is the MF and man. True. Actually true. Why does symmetry breaking generate mass in the standard model? It's because, yeah, so I mentioned this the other day, but so you have symmetry breaking of the Higgs boson. That's the symmetry breaking that happens, the spontaneous symmetry breaking. The Higgs field, rather, it breaks down so you end up with a non-zero vacuum expectation value. And in the direction that preserves the vacuum expectation value, so think of it like a Mexican hat potential, so you can roll around the brim of the Mexican hat without changing the potential. It's called that, don't ask me why, it's a sombrero, literally. That direction is free, and it ends up getting eaten by the W and Z bosons. And so they accumulate mass because now they have 3 degrees of freedom rather than 2. That's where the mass comes from, and then all of the other masses come from particles coupling to the Higgs vacuum. Doc, listen, all we want to do is travel around like they do in Star Trek. I dig ditches, you do smart stuff, make it so. Look, people have been asking me to make transporters a reality for a long time. It's hard. Sean Carroll is an atheist. True. Which dark matter theory do you think will turn out to be correct? I don't know. I mean, if I had to put money on it, I would bet it's probably a particle. If I want to come into the live, should I be in the guest waiting spot? You should be, yeah. Let's bring up Sparta MC from the guest waiting spot. Sparta, how's it going? You have to unmute yourself.
Hello, sir. How are you?
I'm doing all right. What can I answer for you?
I was just it was just a a general question. I wasn't sure if I have two questions, actually, if that's okay.
Sure.
My first question is, what kind of product do you put in your hair to make it so glorious?
I don't know, whatever my wife buys.
Okay, all right.
I could tell you the color
That's a
of the
good word.
bottle. The bottle's purple.
Purple. Okay.
That's such a man
That
answer, by
stuff
the
is-
way. Like, it's the most man answer that exists.
It makes perfect sense. That stuff is silky smooth, and I get jealous of it every time you pull it
I'm
out.
glad you do.
My second question, it involves black holes.
Mhm.
I was curious. I'm not, I'm not a huge physics guy. I took some physics classes in college, but is there a way that maybe a black hole, we call it a black hole, but is it possible that its spherical shape comes from the fact that it's more of a gathering of mass that is converging itself back into like some interstellar object?
That's what it is. Yeah, it's just a whole bunch of mass in like one really tiny area.
But the gap, is it possible for it to gather enough mass that it stops being like a black hole and turns into
No.
like okay.
No. So once it's a black hole, things will keep. So what makes something a black hole is kind of two things. One, you need density, and the other is you need mass. And it's not just that you just need density or just need mass. You need that the mass is in a small enough area so that well, okay, let me back up. So depending on if you took all of the mass in Earth and then you like fluffified it so that it was like less fluffy or less big, sorry, so that it was bigger but the same mass, like you like made it like cotton candy or whatever, the escape velocity of the Earth, like the amount of speed you would need to leave the surface of the Earth, would go down. And that's just because even though the amount of mass is the same, in some sense you're further away from the center of mass because it's spread out more. And
Yeah,
so
that makes sense.
the idea is that if you compress mass into a smaller volume, the escape velocity goes up. In order to escape from the surface, you have to basically, you're closer to the center of mass, so the gravity is stronger, so you have to be moving faster. And so the whole business of a black hole is that the mass is so compressed that the escape velocity is faster than the speed of light. And so the point is that regardless of how much mass, if anything falls into it, that mass will also end up at the center. And so what will inevitably end up happening is just that the the escape velocity will never get smaller, because the escape velocity, once it's already inside, being inside that event horizon limit is the place where the mass has to be for the escape velocity to be the speed of light. So if you like built a shell around a black hole, like a shell maybe like a mile away from the event horizon of a black hole or something like that, then you could escape from that shell, because that shell, then you are further away from that center of mass. But if you're just talking about the black hole itself, not like something outside of it, then no, it'll never be able to get bigger. It'll never be able to outgrow its escape velocity in some sense.
Okay, that makes sense. That does make sense.
Good. Go ahead.
If the mass is so high, for instance, could we increase the amount of energy going into the black hole to decrease its black holification?
No,
That
because
makes
the
sense.
energy will just contribute to the mass.
Energy will contribute to the mass.
E equals
That
mc
does-
squared and all that.
Okay, that comes into play. Okay, because the energy divided by the squared velocity of light speed would equal a mass that just. Okay, well then that makes sense. So is there a way to de-black hole a black hole at all?
Nope. Okay, well, sort of, but no. So this is a thing that not Einstein, that Stephen Hawking came up with in 1975, I want to say. So black holes, if you just leave them on their own, they do eventually disappear. They kind of like fade away. It's called evaporation. And they do this by leaking energy out very, very slowly. And like, however slow you're thinking it is, it's like way slower than that. It's like if you take a black hole that's like, if you take like a normal black hole that just kind of like wanders around because a star exploded, it would take like many orders of magnitude longer than the current age of the universe in order for them to decay, in order for them to evaporate completely. But what happens is that they never stop being a black hole until they stop existing entirely. They will just become smaller black holes, less mass, and so their event horizon gets smaller, until eventually you know, they've leaked out all of their energy and they just cease to exist. But they never are like just an object without an event horizon.
Okay. Well, thank you. Thank you for explaining that. You explained it well, and I understand it better now.
Good. I'm glad I could help.
That was
Anything else?
Yeah. No, that was it. No, just those two. If you ever figure out what that purple bottle is, I'll be on one of the next streams.
I think somebody in the comments said it's Aussie, and I think it's Aussie because I think it has like a an avocado on it or something.
Oh, okay.
If
All right,
let me Google it because I don't want to go run to the bathroom really quick. Yeah, it's Aussie. Yeah, it's Aussie.
I'm gonna give that
That's
a
exactly
try.
what it is.
It works so well on you.
Well, I appreciate that. Yeah,
yeah.
it makes my hair not feel greasy, which I like. So,
And it looks great. All right. Well,
Well,
thank you, sir. I appreciate your insight.
all right, take care.
Bye-bye.
All right, let's. We do have a super chat. We have a super chat from Christopher Sanford with the £2. What happens if black holes collide? They merge and they become one. Their event horizons actually like kind of like bulge out, and then they like overlap, and then once they overlap, they're never separating again. They just kind of ring down and become a nice little ball after long enough. Just want to make sure that I answer all of the questions that are in the chat. You know, it's hard digging ditches every day, more dirt. Yeah, I can imagine. Do waves feel clearer as value patterns rather than slope patterns? I don't know what that means. In Star Trek TNG, there's a scene where Captain Picard asks to bring the Enterprise to a full stop, but if they're in deep space, what are they stopping relative to? Probably, my guess is probably like the CMB, or maybe they're full stop relative to like the galactic center. It never made sense to me either. I'm not very well informed on physics news, but I see a lot of pop physics videos recently stating recent evidence that the expansion of the universe is slowing down, reversing. Any truth to it? Kind of, in that there is some people claiming that we have evidence. So there was so the evidence that it's reversing is not. There's no evidence that's reversing. There is a team out of South Korea that has analyzed some data, some new data combined with some old data, and they have suggested that the way that we were interpreting that data in the past was wrong, and that if you interpret it correctly, then that would indicate that the expansion of the universe is slowing down. Now, that's pretty fringe. It's a pretty fringe take, but people are looking into it seriously. Then there's better evidence that it's not that the expansion of the universe is slowing down. In fact, it's still slowing up. But the rate at which it's slowing up, it's still speeding up, but the rate at which it's speeding up, the value of its acceleration is decreasing. So it's still expanding at an ever increasing rate, but the rate at which it's expanding at an ever increasing rate is going down. There's some evidence for that too. This is new evidence based off of an instrument called the Dark Energy Spectroscopy Instrument. It's called DESI. And again, this is still fairly contentious, but there's at least a better, there's more evidence for that. And now there's questions about how the data is being interpreted and whether that's giving us a false signal and all of this stuff, but there is some evidence for that. From Garain with the $2, could you shrink a black hole by feeding it antimatter? No, you just make it heavier. Matter and antimatter both have positive mass, so it doesn't buy anything. Chase says, I saw this just a second ago. What did Chase say? Please be... Where'd the comment go? What? Oh, Chase deleted it. Okay. I'm like, where did that go? For a minute there, I thought slowing up was some physics term I didn't know. No. Wouldn't the Star Trek starship simply be stopping relative to the vector they're traveling? There is no relative to the vector they're traveling. You can't stop with respect to yourself. You're always stopped with respect to yourself. It went away. I said, please slowing down. I need this. Yeah, I need that too. All right, let us bring up Marcus Hale. Marcus Hale, how's it going?
Dr. Blitz, what's going on?
Doing all right.
All right. You don't have to answer this. I know this is like probably a lot to just throw on like a person on the internet, but can you just like briefly explain like how relativity kills the A theory to me? Because I always like hear people say that, but I don't like
Yeah.
understand it.
Yeah, and I can even pull up a diagram for you, which might help. So, okay, first we have to accept that one of the features of relativity is something called the relativity of simultaneity. Now, the underlying principle, and this is just special relativity, by the way. This is no, there's no theory of gravity involved here or anything like that. So, let me open up a diagram for you, and I can show you what I mean. So, what relativity of simultaneity is? Let me back up. So the business of relativity is that regardless of your inertial reference frame, we should treat, like, the laws of physics are the same for everybody, regardless of how fast you're moving. That's like the first insight that Einstein has in special relativity. And so in some sense, the underpinning philosophical idea is that everybody's reference frame, everybody's conception of now, should be equally real, right? That's the core idea that gets us to B theory. You good? Marcus? Marcus, you there?
Yo.
What was that?
Hello. Oh, sorry. I had like an AirPod in, so it was like messing with the microphone, I guess.
Yeah, okay. So the idea is something like, if everybody's perspective is equally valid, then everybody's idea of what now is should be equally real. Like, there's no reason why my now should be more real than your now, just because my now is, just because I'm moving at some speed and you're moving at some other speed. Like, whatever your now is, it should exist just as much as my now. So that's the idea. This is like that there's some symmetry that it's kind of democratic. And then the question is, well, what do our different nows look like when we're moving at different speeds? And it turns out that they kind of tilt with respect to one another. And I'd love to find a better diagram than this one. Oh, this is actually a really good diagram. It's a really good diagram. Here. Okay, let me pull this up.
How do they even like figure this out that like people's nows are different? Because like wouldn't it like
so it just follows from special relativity. Like, it just follows mathematically. So here's the diagram to look at. So let it reset. Okay, so here's what your nows look like. That's what like when you're not traveling, when you know you're moving exactly as fast as you are. What you'll find is that A, B, and C might be simultaneous. But from somebody else's perspective, A, B, and C, depending on how fast they're moving, A, B, and C are not simultaneous. A could be before C, C could be before A, depending on what direction you're moving in and how fast you're moving. And so the point is that if A, B, and C, these are different events in space-time, think of like people turning on light bulbs at some time and at some place. If these are different events in space-time, and they're simultaneous from one person's perspective, and they're not simultaneous from another person's perspective, then it seems like it would mean that one person's perspective is somehow in the future of another person's perspective. If you're looking at some distant place, notice how the center never changes, but A and B do change. And the point is that when we're moving at 0.3C in this direction, now C is in the past, now C is in the future, because what constitutes a moment of time is this white line moving forward. And so you can see how what I think of as now might be different from what you think of as now, and if they're both equally real, then my present can be in your future. And if my present exists, that means your future exists. That's how we get to B theory from relativity. That's basically the idea. And I know it's a lot to throw at you, but the point is that it's from these kinds of diagrams, and these kinds of diagrams accurately describe what actually happens in the real world. Like, this is stuff that we can test empirically and turns out to be true. The only thing that you might not buy into, which is, you know, maybe if you don't buy into it, fine. It's just that, in fact, actually, there is one special speed. And if you're not moving at that speed, then what you think of as now, you're just wrong about what now is. And you could say that, but it'd be a little counterintuitive.
You know, I think maybe it's just like harder for me to understand because I don't have like a science like background, or I guess like I don't have like a understanding of like some of the lower level concepts. Does like space-time
Hopefully I can help.
like, yeah, so well, yeah, I'm probably like the best guy for that actually, out of pretty much everyone that I know of. Does like when so okay, I guess I'm confused. I understand it, but I'm confused about a lot of things. All right, let me take a second to like
Sure.
collect.
I wish I could like pause this. Or it's just gonna go forever. That's fine. It can just go forever.
So okay, we're in 4 dimensions, you could say. So x-axis, y-axis, z-axis, and then time.
Yeah, but you can forget about all of the other axes except x and time. Like the other axes are just going to make it more confusing. The y and z, just forget about them for now.
Just in terms of like relativity, at least.
Yeah. I mean, like you can do relativity in 4 dimensions, it works fine. It's just harder to visualize, which is why I recommend just thinking about it in terms of 1 dimension of space and 1 dimension of time.
So okay, how does I know that with like certain massive objects, will like bend time, or they'll bend space, and then time will like stay constant, or maybe it's the other way around. But I'm
Both
just not sure
change.
why that happens. Like why is it that if you have like a black hole, it like bends the graph?
That is a far deeper question and has nothing to do with this whole business about B theory of time and special relativity. So there's special relativity, which is just about like moving in just like moving. There's no gravity anywhere. It's just you're just moving at different speeds relative to things, and what are the consequences. General relativity is what happens when you take that and you add gravity to it. General relativity is far more complicated, but it's kind of built on the back of special relativity. But all you need is special relativity in order to get to the B theory of time. Now, as to why masses curve space-time, it just seems like that's a thing that masses do. This is probably not like, how physics doesn't usually answer why, it kind of answers how? Well, I can tell you how it curves space-time, but not why.
Well, how? Okay, is there a way to like explain how without it like?
No, it's just there's a formula. There's a formula that tells you how.
Oh, okay. Yeah, I don't know. That's one thing about physics. I think it takes a lot from, or like physics and like philosophy go hand in hand, because with like metaphysics you can try and like figure out why this stuff happens, but a lot of people it's like not really easy.
Well, yeah, that's true. I think that as long as you're letting your metaphysics be guided by the physics rather than going in the other direction, I think that metaphysics can be very handy.
Yeah. All right. Before I hop back down, dude, I just want to say I've been like seeing you like almost like learn a lot about philosophy from that guy Ian. It's
Ian.
pretty like pretty fun to watch you now just like go on like YouTube and just like you got all the stuff now about like necessitarianism under your belt.
Oh yeah,
so.
I mean, I'm not necessarily a necessitarian, if you will, but yeah, so I've learned a lot about the Bible from Justin and a lot about philosophy from Ian. I've also learned a lot about philosophy from Danny. I don't know if you know Danny. He is Danny is the OG philosophy teacher on TikTok in my view, and he's a good buddy of mine. But yeah, it's been fun. It turns out that you actually can learn things without reading if you know the right people.
I mean, yeah, that's like it's actually like I've been like listening to like just like TikTok lives and then like the YouTube like recordings of the live streams. It's almost like I feel like how like when babies learn a language just from like hearing like the adults speak it.
Yep.
That's what I feel like.
That's exactly
really,
what it
like,
is.
I don't have like a deep understanding of it yet, but I'm like
Sure.
learning some of like the terms and like some of the, I know what like metaphysics are, and I know epistemology, and I know all about virtue ethics because you guys like yap about it all the time.
Well, I'm not a virtue ethicist, and I think that's cringed and lonely pilled. But Ian does yap about virtue ethics a lot. The other thing that can be helpful is once you know what some of these words mean, then you can actually go start reading things like the Stanford Encyclopedia of Philosophy, which is very handy.
Yeah, I want to read the Plato stuff about like numbers.
Oh, Plato sucks. I mean, like you can read it, and you probably should, and I definitely did read it when I was in college because I had to. But like Plato sucks. They
really?
all these ancient Greek philosophers, they suck. They're so out of date.
No, I know they like are really out of date. And a lot of their stuff is like based on other false things that they thought at the times. But I know like for like Aristotle at least, like he laid out a lot of groundwork, and then like a bunch of like neo-Aristotelian like philosophers came along in like the 1800s, and they said good stuff.
Yeah, that's true.
All right, I'm gonna get out of here.
All right,
nice
take care.
You, man.
We have a super chat from Grimmy with $5. Are some parts of space ever in a still state until interacted with physical phenomena? Probably not. I don't know what it would mean for a part of space to be in a still state, but the point is there's always photons traveling through things. In fact, I saw an estimate somewhere. I want to pull this up. Maybe I should make a video about this. Because this might be interesting. So I think it's like 400 or something like that. No, apparently I was very wrong. The internet is telling me. Oh no, I'm sorry. Okay, I kind of am right. So in any cubic centimeter of space, there's something like 400 cosmic microwave background photons. So like you're never gonna find a cubic centimeter of space that doesn't have at least a few hundred photons in it, is the point. So no, to answer your question. All right, let me answer a few more questions. Not gonna lie, when I first read and sort of understood unitary groups in the standard model and how the three forces pop out of the math, I was kind of certain that we would be able to fit gravity into it. Are there any attempts to explain gravity as a gauge theory, which were successful, semi-successful? Yes, this is what loop quantum gravity is. Loop quantum gravity uses a coincidence, basically, between between SO3-1 and S2 cross, or SU2 cross SU2, if I remember correctly, and then they kind of try to do a gauge group thing for gravity. There's got to be a way to cheat around the speed of light. We're humans, we have imagination, we can do it. Everyone in here has big brains, think. Yeah, we should. But no, I don't think that we will. Oh, actually, we're in 11 dimensions. They just go to another school, but trust me, they're there. Ah, yes, the classic string theorist. Danny is the GOAT, I agree. Do waves feel clear as value patterns rather than slope patterns? I don't know what that means. All right, let's bring up First Amender, who's been waiting very patiently. Thank you so much for waiting, First Amender. First Amender, how's it going?
Hey, what's up? How you doing, Dr. Blitz?
I'm doing A-okay, First Amender. What can I do for you?
All right. So I think I actually have a really solid defeater for God, but it's going to require somebody who has way more physics knowledge than I do.
All right, so then what's the question that you need? Go ahead.
All right. Oh, and I guess what I'm asking is poke holes in this as much as you possibly can, because I can't find any.
Okay.
Maybe you can help me out. So we obviously can't exhibit any instances of a miracle happening within space-time. And what I mean by that is work, the physics definition of work, independent of any known forces, and that it is basically unexplained. It would have to have some, I guess, a G that isn't gravity. Does that make sense?
It would have to there'd have to be some source for the force, is what you're telling me.
Well, it would have to, like, it would be an unknown force that cannot be
Yep.
explained by anything that we can empirically verify.
Yep.
So since we cannot exhibit that, I posit that God does not interact within space-time. And so the only place that God has to hide at this point would be where the deists would argue, which would be like the universal first cause mover, right?
Mm-hmm.
So I think I can actually disprove this one as well, and this is where it gets interesting. So if we presume a universal first cause mover, as in exists beyond space-time, why would I presume any anthropomorphism, such as the act of decision-making or thinking or desire?
Well, unfortunately, hate to be that guy, but asking a question is not a defeater. Right.
Okay, all right. So it is not logical to presume any anthropomorphism without there being the framework that enables an anthropomorphism.
I mean, that'd be a claim that you'd have to justify, right?
So,
but also,
I mean,
like you're making an argument about what you should believe, not what's true. And so it's not really a disproof of God, if you will. It's not a disproof of the existence of God. It's perhaps an argument against the belief that a God exists. that might be plausible. And it's an argument. It's a similar kind of argument that I would often make, but it's not an argument against the existence of God per se.
Hold on. So you said, okay, like maybe I'm using the term proof incorrectly then.
Yeah, I mean, you're trying to show that it doesn't exist, not just that you shouldn't think it exists.
Okay. So even if I presume that there was something that made the universe, if I presume that to exist, there is nothing indicating an anthropomorphism. And so the idea
right,
of
but
thinking,
absence of evidence is not evidence of absence, right?
Well, sure, I would say so.
So you might say that there's no evidence that it's anthropomorphic, but that's not an argument. That's not like an argument that it is not anthropomorphic.
I see what you're saying, except how exactly can there be an anthropomorphism if it is beyond space-time?
Well, so most theists are going to say something like, oh, it's actually not anthropomorphic. That's just a thing that we do to try to understand how it behaves. But it's actually like something much more fundamental, much more foundational, and we kind of just talk about it by analogy.
Now, this is where if I can get somebody to argue in that favor, then at that
that's
point,
what like most Catholics will argue.
Gotcha. Well, then we wouldn't even be talking about God because it doesn't have a desire or.
Well, they would say that it has a desire. It's just not a human desire. Or it has a will. It's just not a human will.
The desire is an anthropomorphism. It is beyond.
Well, no, I mean, like humans are not the only things that have desires, right?
That's correct.
So like it's not necessarily anthropomorphic. Well,
okay,
arguably, yeah, that's a separate argument.
Because it's
well,
not
that's a separate argument that I believe, but that's a separate argument. It has nothing to do with anthropomorphization.
Okay, maybe I gotta change the term anthropomorphic. I guess I'm like we're attributing temporal characteristics to something that's not.
Yep. And then you just have to demonstrate how minds can't be temporal, or minds have to be temporal rather. But
yeah, because the act of decision making requires temporality.
That's exactly an argument that I've made before.
Oh, okay. All right, thank you.
Of course. Take care.
All right, peace.
All right, let's bring up. Let me read a few questions, and then I will bring up another guest. From your physics intuition, do you think the Coida formula is a coincidence or is a sign of some underlying relationship between lepton masses? I don't know. I really want it to be an underlying relationship, but it seems like a coincidence. And from helping Maga deconstruct with the $5, thank you so much. Can you explain how the universe is expanding faster than the speed of light? Is there a way to determine the size of the universe beyond what we can observe? It's not. The universe is not expanding faster than the speed of light. The universe's expansion doesn't have a speed in like miles per hour or meters per second. The universe has a doubling time, which means that any given block of space that's not, gravitationally bound up or whatever, is going to double in size roughly every 10 billion years. Now, if you took a sheet of paper and you doubled it and you just started stretching it so that it doubled in size every 10 minutes, you could, I guess, attribute like a meters per second speed to it by measuring like the distance between the two edges of the square or of the piece of paper and asking, how is that distance changing with time? But that's not telling you about the expansion. That's telling you about the growth rate of the distance between two arbitrarily chosen points. Now, if you do that same kind of reasoning for the edge of the observable universe, then you would find that yes, the edge of the observable universe, like the width of the observable universe is growing faster than the speed of light. But that's not like the expansion being faster than the speed of light. That's just like the expansion causing the distance between two things to grow faster than the speed of light. Now, is there a way to determine the size of the universe beyond what we can observe? Yes, sort of. If the universe is finite, then we can try to figure out the size by looking for artifacts in the sky and looking for kind of repeated things. So if it's a finite size, then things would kind of loop back on themselves. We can also look for signs of curvature, which would indicate size as well, like large scale curvature. And from Akeem Francis with the $10, based on the train experiment, that motion is somehow changing the space between objects. Does that mean that the energy causing the motion velocity is responsible for the change in the speed in the space? No. Kinetic energy is also relative. Energy is a relative quantity. So no, it doesn't. It's not costing energy to change the space. It's just that the amount of energy that things have is different. And let's bring up one more guest from Bubrub. Bubrub, how's it going?
Good. What's going on?
Not a whole lot. Bubrub, what questions you got for me?
Yeah, I just wanted to disagree with something you said earlier.
You realize that this is a question and answer live stream, not a debate live stream?
Yeah, I guess I'll turn it into a question.
Okay, as long as it's good faith, sure.
Yeah. So I think that physics cannot replace metaphysics because every scientific investigation already presupposes metaphysical commitments.
Sure, I didn't say that it can replace it. I said that you should let the physics lead the metaphysics.
Why though? How does that make any sense?
Because, like, look, there are some observations that you have, and if your metaphysics are in somehow direct conflict with the observations or whatever, then I think that you probably should be abandoning those metaphysics and rather using metaphysics that don't directly contradict our observations. That's all.
Okay.
That's all I'm saying. I'm saying that, like, you shouldn't take some metaphysical position and then try to force physics to fit that position. You should make sure that whatever metaphysical position you have, it's compatible with the way that we understand physics. That's all. It's not particularly contentious.
Yeah, so the idea like the external world exists, logic is valid, induction works, all of these metaphysical ideas.
Sure, and I wasn't referring to those things. I was referring to more specific things about metaphysics, like the nature of time, for example, or like, the nature of space, or questions about, mereology, these kinds of things.
Okay, yeah, then I don't think we disagree, because I think I was talking to another atheist. He just said that, metaphysics is just the byproduct of atoms and movements of atoms. So I just thought that was not something that physicists hold themselves, right?
I don't know what the metaphysics of most physicists are. I don't talk about metaphysics with physicists. Talk about physics with physicists.
Right. Good point.
All right. Well, Bubrub, thank you for being here. It is past the time that I should end the live, and hopefully I answered your question, clarified. So I'm gonna let you go, but thanks for being here, bud.
Thanks.
So yeah, it is that time. There are no other. I mean, there are a few guests who have been waiting, and I apologize for not getting to. But I do have to end the live. I need to go eat lunch and drink coffee, then record then record a video, edit the video, and then post the video. And then, do I have a meeting? Do I have another meeting today? God, I've been so busy lately. Okay, I don't have another meeting this afternoon, so I'll have time to get to work on some stuff. But we do have some some cash apps that I want to read. Make sure I don't miss them. From Grimlock with "Have you quenched your thirst?" with the $5. Thank you so much, Grimlock. And from Rob with the $2 for W Dr. Blitz, which I always appreciate. All right, I think that is everything. Oh, oops. Just double checking something. Okay, we're good to go. So guys, I will see you guys tomorrow for some more debates. Until then, have a good rest of your Tuesday. Did it say Wednesday? Have a good rest of your Wednesday.